Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 8 Notes 2, which is adding and subtracting rational expressions. So when you're adding and subtracting rational expressions, we're taking a look at making sure that we have like terms, which is how we've done adding and subtracting in the past. So first, let's take a review of what we did on the previous note sheet, and that was that we wanted to simplify these radicals down. So we take a look at 40, and I want to figure out what divides 40, and I want to look for perfect squares. So I did 4 and 10. 4 can be broken down to 2 and 2, and 10 can be broken down to 5 and 2. So then underneath my radical I have 2 times 2 times 2 times 5. So I have a pair of 2's that I could take out. So I take that pair of 2's out, and left underneath the radical I have 2 times the square root of 10. Taking a look at 24, again looking for perfect squares. So I use 4 and 6 because 4 I can break down to 2 and 2. 6 I can break down to 2 and 3. So then, left underneath the radical, I have 2 times 2 times 2 times 3, and then I have 1, 2, 3, 4, 5 x's. So now we want to find our pairs. We have 1 pair, 2 pair, and 3 pair. So I have a pair of 2's, a pair of x's, and another pair of x's. And then underneath the radical, I have 2 times 3 times x. So now I want to multiply that out. 2 times x times x. Well, 2 stays the same. X times x is x squared. 2 times 3 is 6, and then we're going to tack on an x. So we have 2x squared times the square root of 6x. So now let's talk about adding and subtracting radicals. How do we do this? Well, first thing we want to do is to simplify the radicals. And then you're going to combine like radicals. That's kind of the same as combining like terms. For example, you can do 5x plus 3x. You can add that to make that 8x. But if we have 5x and 3y, we can't add those two together because they're different. Okay, so then this is taking a look at the example. So we can take and we can add 4 to the square root of 5 plus 7 times the square root of 5. But we can't take 4 times the square root of 5 plus 7 times the square root of 3 because the radicals themselves are different. That makes them not be like terms. All right, let's take a look at this. So this is really simple to start off with. So when I take a look at this, first I notice that they're both square roots of 3. So since they're like terms, that means I can add the number on the outside. So I'm going to take 5 plus 7. And then I'm going to leave it as the square root of 3. Okay, so when I add them, I just leave it as the square root of 3. Then I have 2 square root of 5 and then, 2 square root of 2 and minus 6 square root of 2. I can add those two together because these both have radical 2. So then I'm going to take 2 minus 6. 2 minus 6 is negative 4, and then again, my radical 2 is going to stay the same. And then I need to add this plus 5 square root of 5 at the end. So those two terms cannot be added together because they have different numbers underneath the radical sign. So next, let's take a look at this next one. So we can go ahead and we can combine these two terms because they're both radical x. So then we can add the coefficients. So 5 minus 3 is 2. So I have 2 square root of x. Then I'm going to go ahead and add the square root of 2. So I have 2 square root of x plus the square root of 2. Now, before we're going to take and try and add number 6, because we can't right now, we need to make sure both radicals are simplified, which 27 is not. So I can break 27 down to 9 and 3, and then I can break 9 down to 3 and 3. So then I end up having 4 square root of 3 minus the square root of 3 times 3 times 3. So then I notice that I have the square root of 3 that I can take out. So I have 4 square root of 3, and then I'm taking out a pair of 3's, and then left underneath the radical still is 3. So I have 4 square root of 3 minus 3 square root of 3. So 4 minus 3 is 1, and then we're going to write it as square root of 3. Well, here's the deal with 1. If you're multiplying a radical by 1, you can technically write that as the square root of 3. So that's going to be my final answer, is just the square root of 3 for number 6. Next, let's take a look at number 7. So for number 7, we want to simplify all of these radicals. So let's start with 12. So with 12, I have 4 and 3, and 4 breaks down to 2 and 2. With 27, I have 9 and 3, and 9 breaks down to 3 and 3. Well, I'm going to be smart about 48 because actually, when we look at 48, 16 goes into 48. 16 and 3. Well, 16 is a perfect square that breaks down to 4 and 4. And I'm just going to stop. You could keep breaking this down to 2 and 2, but I already have a pair, so I'm just going to stop. So let's go ahead and let's write this out. So we have 2 times the square root of 12, which is 2 times 2 times 3. Minus 3, and then underneath the radical I'm going to have 3 times 3 times 3, and then plus 2, and then I'm going to have 3 times 4 times 4. So let's go ahead and find our pairs. Well, we have a pair of 2's on this one. So I'm going to have 2 times 2, and then left underneath the radical is 3. For the second one, I can take out a pair of 3's, and then I'm going to have 3 times 3, and left underneath the radical is 3. In this last one, I have a pair of 4's, so then I'm going to multiply it by that coefficient, so I have 2 times 4, and left underneath the radical is 3. So now we just need to multiply these out, so I get 4 square root of 3 minus 9 square root of 3 plus 8 square root of 3. So now I want to add all my square roots together. So I'm going to do 4 minus 9, which is negative 5, plus 8, which is 3. So the final answer to this guy is 3 square root of 3, which you would have never guessed looking at the original problem, right? Okay, let me give myself some more space here. So let's take a look at this next one. So we're going to take 8 and simplify it down to 4 and 2. And 4 breaks down to 2 and 2. So now that's going to be 3 times 2 times 2 times 2. Then splitting up 32, well 16 goes into 32, and we can use 2. So that's going to give me a pair of 4's. So then plus 5, and then underneath the radical is 2 times 4 times 4. And then 18 we're going to break down to 9 and 2, and then we're going to break that down to 3 and 3. So that's minus 4, and then the square root is 2 times 3 times 3. So out of this first group, I can take a pair of 2's. So that's going to give me 3 times 2, and left underneath the radical is that square root of 2. In the second group, I can take out a pair of 4's, so I'm going to have 5 times 4, and left underneath the radical is that 2. And out of the second group, I can take out a pair of 3's, so I'm going to have 4 times 3, and left underneath the radical is 2. So 3 times 2 is 6, so I have 6 square root of 2, plus 20 square root of 2, plus 12 square root of 2. So then you can go ahead and add all these together. 6 plus 20 plus 12. You add all of that together. Oh, and this should be minus 12. That's my issue. So you minus all of those out. You get 26 minus 12 is a negative, or is 14, sorry. And then square root of 2. All right, let's take a look at this perimeter problem. So we want to find the perimeter of the rectangle. So if this is the square root of 8, then this is also the square root of 8. If this is 3 plus 6 square root of 2, then the other one is 3 plus 6 square root of 2. And that's just by definition of a rectangle. So before I go any further, I'm going to simplify the square root of 8. So the square root of 8 you can simplify into 4 and 2, and then 2 and 2. So I'm going to have the square root of 2 times 2 times 2. So I could take out one pair of 2. So I'm left with 2 square root of 2. So that's what these two sides are going to become. So to calculate out the perimeter, I need to add all of the sides together. So I'm going to do 3 plus 6 square root of 2. And then I'm going to, for 8, use 2 square root of 2, plus 3 plus 6 square root of 2. And then for that 8, I'm going to use, again, 2 square root of 2. So first of all, I can add these numbers together. I can do 3 plus 3, and that's going to give you 6. And then I want to take and add my radicals that all have square root of 2. So I have this one, this one, this one, and this one that all have square root of 2. So 6 plus 2 plus 6 plus 2. And that's going to give us, let's see, 16. Okay, so that's going to give us 16 square roots of 2 when we add all of those together. Okay, so then our label that was given to us is yards. So this is going to be yards for your final answer for number 9. Let's take a look at number 10. So you and your friend are working on a sailboat. The distance in miles you can see from the horizon is modeled by that equation given there, where h is your eye level height in feet above the water. So your height is 32 feet and your friend's level is only 18 feet. Write an expression that shows how much you can see over your friend. So that's basically going to be a difference. So we're going to start by plugging me in. So I'm going to do, is that a 3? It's hard to see in there. Yep, 3 times 32 divided by 2. Now that's going to represent me. And then I'm going to subtract off my friend. So all I'm doing is plugging in those h's. And her height was 18 divided by 2. So now I'm going to kind of calculate that out a little bit. Okay, so we're going to do 3 times 32 divided by 2, and that's going to give us the square root of 48, minus 3 times 18 divided by 2 is going to give us the square root of 27. So now we want to add and subtract those. So for 48, again, I want to use 16 and 3. Because when I use 16, I can break it down to have that pair earlier on, and I can use 4 and 4. And then when I have 9 and 3, I can split that up to be 3 and 3. So then left underneath the radical, I have 3 times 4 times 4. And then I'm subtracting, and I have 3 times 3 times 3. And then I have a pair here, so I could take the pair of 4's out, and then I'm left with the square root of 3. Here I have a pair of 3's, so I could take that pair of 3's out, and then I'm left with the square root of 3. So now I can subtract those. 4 square root of 3 minus 3 square root of 3 is going to be 1 square root of 3. Again, I can just write that as a square root of 3. And our label for the distance d is also going to be in feet. So I can see the square root of 3 feet farther than my friend. Next, let's take a look at number 11. So now we're talking about a pole vaulter's velocity is 8 times the square root of their height. So you are a pole vaulter that reaches 20 feet, your opponent only reaches 16. And we want to find the difference in velocity or speed of how fast they were running. So what we're going to do is we're going to plug in me first. So my velocity is 8 times the square root of my height, which is 20. Then my opponent is going to be 8 times the square root of her height, which is 16. So 20 I can break down to be 4 and 5, and 4 I can break down to 2 and 2. So then I have 8 times the square root of 2 times 2 times 5. And then 16 I can break down into being 4 and 4. So what happened here is everything worked out to be a pair, which makes sense, right? The square root of 16 is 4. So because everything worked out to be a pair, when we take the square root, everything is going to come out. There is not going to be a square root. So let's go ahead and let's start by taking this pair of 2's out. So I'm going to have 8 times 2, and then the square root of 5 is left over. Minus 8 times the square root of 4. Since they're both pairs, it's just going to end up being 4. So then I can go ahead and multiply these out. So I get 16 square root of 5 minus 32. And then we want to take a look at what our label is for the velocity. And it gives us that the velocity is in feet per second. So when we go down here, I'm just going to label it feet per second. So that concludes your note video for today. Please remember to take that Schoology quiz. Thank you for listening.